Hello everyone, thank you for looking into my video today on quadratic forms of equations. Okay, if you're going to follow along with the notes provided here, we're actually going to skip past the first couple slides because they're more of an exploratory, something that you should do on your own. So we're going to move to this slide here and build off of what we did yesterday. Okay. So yesterday we talked about the three forms of the quadratic. Today we're going to talk about kind of going back and forth between them, but also practicing graphing as we go. Okay? So let's take a look at our three forms again. They are vertex form. H comma k is our vertex, and then we use transformations to graph that. We've been doing that for a while now. Standard form. If you can rewrite in vertex form, you can do that. If not, you can find the vertex like this. And then this x-axis, the value of the x for the vertex is also your axis of symmetry. And then for intercept form, the two intercepts are easy to find there. Plot those, and then the middle of those would be your vertex for your x coordinate. Okay? So first we're just going to start practicing writing these in standard form. So what does that mean? We want it to look like this when we're done. Okay, so for 1a, we're just going to distribute. And we get 2x squared minus 8x plus 1x, so minus 7x minus 4. And that's your standard form. And for b, we're going to distribute that x plus 2 squared. And then distribute the 3. And finally combine those like terms at the end. Okay, so that's just going from intercept form to standard form and vertex form to standard form. All right, so our goal today obviously is to be able to graph all of these in any form that we're given. So this first one is given to us in intercept form. What does that mean? It means that the x-intercepts are going to be really easy to find. Negative 3 comma 0, 3 comma 0. Let's plot those. All right, now the vertex, the x-coordinate of the vertex would be in the middle of those two. So you can think of it as the average of those two. So for the vertex, you're going to do 3 minus negative 3 over 2, which is, 3 plus negative 3. Over 2. When you find the average, you want to add them together and divide by 2, which is 0 over 2, which is 0. So the x-coordinate of the vertex is 0. That's also our axis of symmetry. And for the y-coordinate of the vertex, you're simply going to take that 0 and put that back into here. So you get 3 times negative 3, which is negative 9. So plotting that. 0 comma negative 9 also happens to be our y-intercept, because 0 comma anything is a y-intercept. Okay, our zeros, that at x equals negative 3 and x equals 3. Okay, that's just the x-coordinates of the x-intercepts. Our domain, like any parabola, is all real numbers. Our range, if we graphed our graph now, there we go. Our range would be negative 9 to infinity. It's increasing here, so 0 to infinity, and decreasing here, so negative infinity to 0. Number 3, this is in standard form. Standard form, which means the easiest thing to find would be the y-intercept. If you put 0 in, you get negative 5 back, so 0, negative 5. I'll plot that right now. All right, the x-intercepts, we can either try to factor or complete the square or quadratic formula. But assuming this factors well, which it does, we get our x-intercepts of negative 5, 0, and 1, 0. All right, now there's two ways to get the vertex. You can do the average of these x-coordinates again, or you can do opposite of b over 2a. Remember what we did right here, right? Opposite of b over 2a. So either of those will work just fine. I'm going to do opposite b over 2a, so negative 4 over 2 times 1, which is negative 4 over 2, or negative 2. So that's our x-coordinate here and our axis of symmetry. To get our y-coordinate, you're simply going to take negative 2 and put it back in here. So it'll be 4 minus 8 minus 5, which is negative 9. That's negative 2, negative 9. This is our axis of symmetry, which means if you take this point and move it over that line, we would get this point right here, negative 4, negative 5 as well. Our zeros are negative 5 and 1. And if we draw our graph in now, our domain again is going to be all real numbers. Our range again is going to be negative 9 to infinity. That's not going to happen every time, just a coincidence, these first two. It's increasing here, so negative 2 to infinity, and decreasing here, so negative infinity to negative 2. Fourth one, also in standard form. So standard form, which means the y-intercept should be easy to find, 0, 2. To find our x-intercepts, we can try to factor that, but it's not going to factor. So you have two options here. You can complete the square and put it in vertex form, which is going to be a good idea, or you can use quadratic formula, which is not always the best idea. So I'm going to put this in vertex form by completing the square, right? 3 squared is 9, so add 9 there, subtract 9 there. And there's our vertex form, which means our vertex is at negative 3, negative 7, and our axis of symmetry is x equals negative 3. All right, for our x-intercepts, well, first let's plot negative 3, negative 7 here on the graph. And let's plot our axis of symmetry. All right, so for our x-intercepts, we can either solve this equal to 0, or we can go back and do the quadratic formula again. But I'm not going to do that. I'm going to set this equal to 0 and solve. Our x-intercepts are at negative 3 plus or minus root 7, comma 0. And our zeros are x equals negative 3 plus or minus root 7. All right, so in order to figure out where to plot those, root 7 is somewhere between 2 and 3. We don't need to know exactly what it is. It's somewhere between 2 and 3. Let's even say we can guess it's 2.5. So that'd be negative 3 plus 2.5, which is close to 0. And negative 3 minus 2.5, which is between negative 5 and negative 6, would be our zeros there. We also know the point negative 6, 2 would be on there thanks to symmetry. And now we have enough information to graph our parabola. So our domain, again, is all real numbers. The range this time is negative 7 to infinity. It's increasing here, so negative 3 to infinity, and decreasing negative infinity to negative 3 here. Okay. Number 5 says, which would produce the graph to the right? So let's take a look at the vertex here. The vertex here is negative 2, 2. So I know I'm going to want my graph to be x plus 2 squared plus 2. Okay? So that would eliminate A and B. All right, now you got to think about, is this graph vertically stretched or vertically compressed compared to a normal quadratic graph? And it's definitely vertically stretched. So the number out in front here needs to be bigger than 1, which means our answer must be C. All Our last three problems here are just some practice solving over the complex number system. I would suggest at this point you pause the video, try these three problems just for practice. Come back when you are done to go over our answers. So the first one, you might think the answer is 58. If you put 58 back in here, you get 58 plus 6, which is 64. And root 64, this is positive here. So this is actually not possible here. There's no solution to this problem. For b, if you divide both sides by -3, take the square root, you get plus or minus 2i, add 1 over 1 plus or minus 2i. For that one. And for c, you can either complete the square or use quadratic formula here. Let's use quadratic formula since we haven't yet today. Opposite of b, plus or minus b squared, minus 4 times a times c over 2a. So 12 plus or minus root 144 minus 56 over 4. And we'll just keep going with this here. So 144 minus 56 would be 88. So we have 12 over 4 plus or minus root 88 over 4. Root 88 is 4 times 22, so 2 root 22 over 4. And this can simplify down to 3 plus root 22 over 4. Okay, that'll do it for today's video. Thanks as always for tuning in, and we'll see you again next time.